Hello friends, today we are going to look at how to reverse a linked list in Python. By reversing a linked list, I mean if we are given a linked list in this format, like head is pointing to 1, 1 is pointing to 2, 2 is pointing to 3, and 3 is pointing to 4, and then 4 is the last node in the linked list, so it is pointing to none. By reversing, I mean the head should point to 4, and then the 4 should point to 3, and 3 should point to 2, and 2 should point to 1, and 1 in the. So 1 was the head previously, and after reversal, it is the last node in the linked list. So initially, we are given with the head. So head is the basically the head of the linked list, and we will initialize three variables. Those are cur to keep track of the current node, prev to keep track of the previous node, and nxt to keep track of the next of the current node. And initially the cur is pointing to head, which is 1, and then prev and next are pointing to none. So when we proceed with the code, we will see like nxt will point to cur dot next. So we are given with this particular pointer over here. So using this, nxt will be set to cur's next, which is this node, and then we will flip the pointer of once next. So once next is flipped to the prev, and prev was none, so once next becomes none. So this way we have started the reversal process. So the next process would be moving the cur forward. So we are keeping track of the next with the nxt. So now cur equals to nxt, and then again nxt will be cur's next. So nxt will move to 3, and we will flip again. So we will so 2's next will be prev, which is 1, and similarly prev will move forward using cur, and then cur will move forward using nxt, and then nxt will move forward using current's cur dot next, which is 4, and then uh, cur's next, which is like 3's pointer, will be flipped, and it will point to prev, which is 2, and prev will move forward using cur, and then cur will move forward using nxt. nxt will proceed using cur dot next, and now we are going to flip again. So force next, which is pointing to none, will start pointing to 3 using prev, and then prev will move forward using cur, and then cur will again move forward using nxt. At this point, cur is none, and we are going to end the loop. And so the head has to be set to prev. So the new head is 4 now. So the new head is pointing to 4 now, and flip this, and yeah, you have learned how to reverse a linked list. Now let's look at some edge cases. So the first edge case is when the linked list has only one node, and the other edge case is when linked list doesn't have any nodes. So basically head will point to none. In both the cases, the reversal operation won't do anything. We will have the same linked list. Look at the code. So this is the class node that depicts the linked list node, and we have an init method here that takes in the value of the node, and also sets next to none. Look at the main method reverse linked list that takes in the head of the linked list and performs the reversal. So here it just initializes three variables as we have already discussed, and then later it starts iterating over the linked list using the cur variable, and it performs all the operations that we discussed, and in the end it assigns prev to head. So the head is updated, and we have the reversed linked list. Now let's run the code. Reverse linked list. For that I'm going to create a new Python notebook, rename it to reverse linked list. Let's get started. So first of all, we'll need a node class that depicts the linked list node, and an init method that takes in the value. and assigns that to the instance at the time of initialization, and it also initialize the pointer to next node, that is none. So this is our class node, and next int linked list utility method that takes in the pointer to the head of linked list and prints the whole linked list in such a format, like the head points to first node, first is pointing to second, and so on, and the last node, fourth, is pointing to none. So if you see this particular block of code, this is a pretty standard way to iterate over a linked list. We take a temporary variable that points to the head of the linked list, and later we just keep updating it to the next of the current node. Next, let's see how to define the main method, that is reverse linked list. It also takes in the pointer to the head of the linked list and returns back. So here the input is head of linked list, and it returns back uh, new head basically. So it returns back the new head of linked list that we need to update. We initialize three variables: cur, nxt, and prev. So cur is for the current node, nxt is for the next node, and prev prev is for previous node. And we initialize cur to the head of the linked list. So basically this is the variable that points to the current node in the iteration, in the whole iteration. And nxt is initialized by none, so ideally this is used to point to the next of the current node, and prev will be used to point to the previous of the current node. Now let's look at how it works. This is the standard way to iterate over a linked list. So we say while current is not none, and then we just set next to currents next basically, so that we can keep track of the next node in nxt. And this particular step is basically where we reverse the linked list. We just say currents next should be previous instead of currents next, and then we just set previous equals to current, because now we want to move ahead, and then current is next. So in this way we just reverse the whole linked list, and in the end we just return the pointer to previous node. So the pointer to prev is the last not none node basically. So if we look at this particular example, the last node is fourth, uh, which is not none. So it should return the pointer to not none node in case a linked list is not empty. So if the linked list is already empty, the prev would be none, and this iteration won't even happen. In that case, it will simply return none. Test what we wrote so far. So for that, I'm going to take some examples. So let's start with the first example, where the linked list would look something like this. Head is pointing to 1, 1 is pointing to 2, 2 is pointing to 3, 3 is pointing to 4. Let's look how it works. Uh, yeah. For that, I'll just initialize head, and I'll initialize it to node of 1. So this is the linked list, and head is pointing to the head of the linked list. And let's try to print this using our utility method, and this is the pointer to head of the node. Okay, so what we see here is we have initialized the whole linked list starting from head. So head here is pointing to the head of the linked list, that is the first node. And similarly, we have initialized the other three nodes here. And next we have seen how to print how it looks, how the linked list looks, just to confirm that the print linked list really works. Okay, now let's try to reverse this linked list. And if you notice, we have to set head to the return of the reverse linked list, because that returns the new head of the linked list basically. So yeah, so once we run this, and let's test if this really worked. Yay, it worked. Now head is pointing to fourth node, fourth is pointing to third, third is pointing to second, and so on. Yeah. Let's try some edge cases. Edge case 1. Edge case 1 is when you have only single element in your linked list. So basically, head is pointing to 1 and 1 is pointing to none. Okay. So your head equals to node of 1. Let's print the linked list when you have only one node, and then try to reverse it, and let's not forget to set the head and print it again. Let's also print an after statement to make it more clear. Okay, let's execute. So this was the linked list before. Head was pointing to 1, 1 was pointing to none, and after that it's the same. So this works. Let's take other edge case, which is when the linked list is empty. So head is pointing to none. And let's do the same steps. Okay. So as you see, this also works fine. Head is pointing to none before and after, and it didn't throw any error. So our code handles all the edge cases, and it's very important to look that the code really handles all the edge cases. Time complexity of our algorithm. If you see here, these three lines will always be there in the code, and they are independent of the number of nodes in the linked list, so they won't account to the time complexity in big O format, big O notation. Here if you see this particular while block, while current is not none, so this particular block runs n times, where n is the number of nodes in the linked list, and the statements inside this particular block are also independent of the number of nodes in the linked list basically. So it just executes these four statements for each node, and so this is independent of n, but this particular while block is dependent of n. So if you have four nodes, this particular block will run for four times, and if it is five, it will run for five times, and so on. And in the end we just return the new head of the linked list, and that is also O of 1. So the overall time complexity of this particular algorithm is O of n. Let's now look at the space complexity of algorithm. This is the main method reverse linked list, and here we have initialized three variables. So for the whole program just we have used three variables, and this is independent of the size of linked list. So if the linked list is of 10 nodes, or if the linked list is of 100 nodes, we would initialize only these three variables, and that's the reason the space complexity is O of 1.